A controversial question in NEET Physics 2025. Which one was it? I could not find any. Well, there was one question which I found a bit controversial. I don't know, maybe I can be wrong or correct, I don't know. But I feel it was that. Sure, please explain it. I want to know that which one was it. Of course, first of all, let me show you the question. It is this one. Must be visible now. Hello everyone, this is Aditya, and today's video is regarding a question of NEET Physics 2025. And I know this year's physics paper was very tough as compared to the previous years of NEET. So I found many questions which were like very difficult to solve in the duration of 1 minute, because you have 180 questions which you have to solve in 180 minutes, which means per question you're getting only 1 minute. And physics was really not like that, that you can solve like all of them in 45 minutes. It's not possible, right? So in the upcoming video, I will make the solution of all the questions which were very difficult to solve in that paper. But right now, there is a question which I showed you also. I feel that it is a bit controversial. Now, I can be correct or wrong depending upon the criteria on which the evaluation is done. For example, the question I showed you, it is a very simple question, of course, but there's something fishy in that which I need to tell. So let's see it and discuss a point, okay? But before that, please do like, subscribe my channel, and please support this video. Now let's start with the video. So this is the question which I feel that is a bit controversial. Why? I will tell in some time. But of course, if you see the question, it is simply 3 times 1, it becomes 3, plus 2 into 3, it becomes 6. So 3 plus 6 is 9, plus 2, it becomes 11, plus 1 by 2 into 4, it becomes 13. So the error should be 13% in this case, okay? It is very simple. But the problem is that when we actually solve this, it should be something else. I'm not telling the answer what will be, but what I feel is that since P is equal to A cube B square C root D, right? Okay. So what is the method to approach that error formula which we are using, right? So we are basically taking the natural log on both sides. We get 3 times ln A plus 2 times ln B plus ln C plus 1 by 2 ln mod D, but of course D is positive, so we don't need to worry. Now we'll differentiate it. So we'll get dP by P is equal to 3 dA by A plus 2 dB by B plus dC by C plus 1 by 2 dD by D, right? It is a derivative D. Okay. Now in general cases, what we do is that we assume that dx is approximately equal to delta x for very small error, right? So we can basically say that dA is approximately equal to delta A, and similarly for the other cases. But this should also imply that dP should also become delta P, right? For the this is the exact error and this is the approximate error, right? Okay, so let's not consider this term for now. Now we are going to do 3 times dA by A is 1%, plus of course we are going to multiply by 100 both sides to get the percentage sign. I'm leaving that step because you know it, okay? 2 into 2 plus we are going to get 2 into 1 plus 1 by 2 into 4, you get simply 13%, right? Error, right? So the error in P is 13%, right? Now the question arises that the error is too large. This is a very big number, because generally we say dP is approximately equal to delta P for a small error, right? But in this case, the error is too large. So in this case, you can't say dP is equal to delta P, right? Since the error is very large. So that is a controversy which I feel, because in this case you can never say dP by P is equal to delta P by P. You can never say this, because the error is 13% in this case. So how can you actually calculate the error in this case? That is a controversy over here. Like there was a question in which the percentage error in momentum was given as suppose 10%. If I remember, there was a question, right? Not this year, but some other year, maybe in JEE it was, right? So in this case, we need to find the percentage error. So we know that, and mass is constant. So kinetic energy is equal to P square by 2m, right? So dk by k is 2 dp by p, right? Which means that the percentage error in kinetic energy should be equal to 20%. But this is wrong. Why? Because in this case, the error is 10%, is greater than 5%. We generally say dp is equal to delta p or some other variable, dx is equal to delta x only for very small errors, right? So in this case, how are we going to evaluate like this one? Let's see. So we can say that initial momentum is p. So what is the momentum after error? It should be like 1.1 p. It should be like this. Okay. Now delta k upon k is simply equal to p final square minus p initial square by 2m, right? This quantity upon p initial into 2m into 100%, right? We are talking about the percentage, right? Of course you know this, since the change is like the final minus initial by 2m, right, upon the initial quantity, right? Okay, this and this gets cancelled, so you have simply 1.1 whole square is equal to 1.21. So 1.21 p minus p square by p square, right, into 100%, which is equal to 21%. So in this case also you cannot say that dk is equal to delta k, and that is the problem which I feel is in this question also, because the error is like 13%. So that is what I mean when I say that this question is a bit controversial. But of course, if we talk about the answer, it should be 13% only, because on calculation we are getting that. But this is a bit controversial, that because while making the question we should know that the error should not exceed more than 5 or max to max 6 or 7%, because then the controversy will start that the maybe this error is not actually the actual error. Okay, so I hope that you learned something from this video. If you did, then please do like, subscribe my channel, and please support this video. Bye bye, take care.